Sometimes a DTF print looks inconsistent even when nothing obvious has changed. The same film, ink, artwork, and the settings are used, but one area looks darker, another looks lighter, and some edges look soft. When this happens, it is easy to blame the ink or the printer. But one important cause sits directly at the boundary between the ink and the film: surface energy variation. Surface energy controls how a liquid interacts with a solid surface. In DTF printing, it determines whether ink droplets spread, stay confined, merge smoothly, and form a constant layer. If the film surface behaves the same everywhere, droplets have a stable condition to work with. If surface energy changes from one area to another, print inconsistency begins. Surface energy is part of rule book the ink follows after it lands. The printhead controls where droplets are placed. The ink controls viscosity and the surface tension. But once the droplets reaches the film surface decides how the droplets wets and spreads. On a higher energy area, ink may wet the surface more easily and spread more. On a lower energy area, ink may remain more confined and spread less. Neither behavior is automatically bad. The problem is variation. If one region encourages spreading and another limits it, identical droplets stop being identical in practice. They come from the same nozzle, but form different shapes on the film. A single droplet does not create the image. The printed layer forms when many droplets land, spread, overlap, and merge. This is called coalescence. For a smooth print, droplets need to spread and emerge predictably. Too much spreading can soften edges or increase saturation. Too little spreading can weaken coverage or continuity. Two droplets placed at the same spacing may behave differently because they land on different surface conditions. One spreads quickly, another remains confined and merges later or less completely. The result is uneven layer formation, tone differently, edge changes, texture variation, and density inconsistency. One confusing part is that it usually does not affect the entire print equally. If a machine setting is globally wrong, the whole image may shift in a similar direction. Surface energy variation is local. One part of the film surface may provide one interaction condition. Another may provide a different condition. So the defect appears in zones, patches, bands, or irregular areas. The ink did not change between those regions. The local surface condition did. In DTF film manufacturing, the printable surface is created through coating and treatment. If coating composition, thickness, treatment, drying, or curing varies, surface energy may vary too. The variation does not need to be dramatic. Inkjet droplets are small, and the printed layer depends on the precise spreading and merging. The film surface needs to accept ink consistency. Another important point from the article is that this inconsistency can accumulate. At the start, the difference may be very small. One droplet spread slightly more. another spreads slightly less, but the printed layer is built from repeated droplet interaction. Once local differences begin, they influence how later droplets join the layer. So small surface variation can become visible print inconsistency, especially in large prints, gradients, solid colors, and high detail artwork. Surface energy variation does not act alone. Temperature and humidity can change ink viscosity, drying behavior, spreading speed, and surface interaction. This can make a small surface difference more visible. Machine deposition dynamics also matter. Droplet spacing, path structure, print speed, furring stability, and droplet timing all influence layer formation. These factors can amplify a surface interaction problem. Print inconsistency from surface energy variation is not simply random. It is not automatically proof that the ink is wrong. It is not always solved by changing one printer setting, and it is not the same as a uniform print failure. The key clue is localized difference. Different regions of the same film and the same print behaving differently. If density, edge definition, or layer formation varies while setting remains stable, film surface interaction should be part of the diagnosis. When diagnosing this issue, do not only ask, did the setting change? Ask, are all droplets seeing the same surface condition? Look at whether the defect is local or global. Notice whether large areas, fine edge, solid fills, or gradients show the variation first. Separate three ideas that are often mixed together. Ink deposition is where the droplets lands. Ink spreading is how it changes shape. And the layer formation is how droplets merges into a continuous layer. Surface energy variation mainly affects spreading and layer formation. That matters because a print can have accurate droplet placement but still look inconsistent if the surface interaction is not uniform. Surface energy variation causes print inconsistency because it changes ink behavior after deposition. The same droplet can spread differently, merge differently, and build a different layer depending on where it lands. When the condition varies across the film, the result is localized inconsistency in density, edge definition, and layer uniformity. The manufacturing lesson is simple but important. Stable settings do not guarantee stable printing if the surface boundary condition is unstable. In DTF printing, print consistency depends on the full system, film surface uniformity, ink behavior, environment, and machine deposition dynamics. To troubleshoot accurately, look at the ink film surface interaction. That is how DTF troubleshooting moves from guessing to manufacturing control.